So our stem starts from our solid block of 6082 aluminium. We clamp it in a vise at the very bottom and we machine the vast majority of this stem in one operation. So we've stopped the machine halfway through and this is what it looks like. So we've got the bores for the handlebar, the bore for the steerer, and some of the finished machining on the ends and the sides all done. On the top edge here, this has just been rough milled. We still have to go through and finish mill this yet. The reason why we make this out of one piece is the faceplate here makes it a lot more accurate if it's machined in one go instead of machining out of two parts. Also, stems very commonly, they don't match up from the faceplate to the body. With it all being machined in one go, it has to match up. There's no way it can be mismatched. It just makes it look a little bit better. When it's finished machining, it looks a lot like this. So you can see we've got all the 3D machining around there, we've got the counter bores, the tapped holes. So, as if the machine were finished, what we would do is we would get this faceplate and we would snap that off, that's the faceplate finished. And then again, you get the bottom bit and you snap that off, and that's both parts almost finished. On the bottom bit, there'd be a little tab left in where that slot is. And all we'd have to do is put that in an end mill and just machine that slot, and that'll take that tab off, and that's that part finished. So we use a similar manufacturing method for the pedal. This starts again from a solid block of 6082 aluminium. Clamped at the bottom in a vise down there, and we machine the majority again in one operation. So we machine all four sides in one go. We start with the bearing holes on either side. We have custom made drills ground up for them, and then we'll go onto the machine on the sides there and there. So when it's finished machining, it looks a lot like this. You can pretty much see that's the whole pedal machined in one, other than this tab that's left on the bottom here. All we would do is just snap that off, and again then we're left with a pedal that's almost finished. So on this edge here, there would be a little tab left from where we snapped it off. Again, we have to put that into a milling machine. We just take one little skim off there, and that pedal is the milling now finished. The axle is also made in-house. So this is made on our star sliding head. There is 2 bushes and 1 bearing per pedal. This is made from a material called EN19T, which is one of the strongest materials you can use making a shaft from. These so far have proved to be unbendable. Not saying they are unbendable, but no one's bent them yet. They also have if you can see the plating on it, it's like a nice black nickel plating on the axle.
That's better.
So this is the software that we use to program the machine out there. Now this is quite a long, complicated program. You can see that down here, there's kind of a lot of toolpaths on it, and looking at that, it doesn't really make a lot of sense of really kind of what's going on there. But what we can do before we manufacture parts is we simulate them, and this can check out it's programmed correctly. It can also check for any collisions in the machine, and it can also see if we can improve it anyway to try and bring down cycle time. So this is the part actually simulated in the machine. This gives us, like I said before, a good idea of what it would look like. So on the sides there, it's just done either the bore holes, and now we're just skimming off the top of the material. This is unnecessary really. It's unfortunate that we had the material that was a little bit thicker than what we wanted to. It's just a bit of a waste of cycle time. Now it's putting on the chamfer on the edge and going and machining on the little grooves on the top. We've machined purposely a load of little grooves all over the top just to give you a little bit more grip on the top of the flat pedal. You'll notice it is machined very much in stages. When using this manufacturing method, we need to keep as much material in the job, so it makes it stronger. If we were to machine all these pockets out straight away and then try and machine the chamfer on the end, it would just bend and it wouldn't work. So as you'll see as it goes along, it starts to get thinner and thinner and thinner after the kind of bulk of the machine's doing it. This takes a little bit longer to machine, but it's the only kind of real way you can do it using this method. Our chain rings are currently made out of flat billet material. So this is first of all we have to put these holes in. This is to clamp it to our jig that we have made specially to hold these chain rings. The first operation, we machine the one face of the chain ring. So we put some of the chamfers on, tough profile, we machine these cutouts, and we also put this is a cinch one, we put the cinch mount in there. The second operation, this will go onto a jig over there, we clamp it down, and we basically do the opposite on this back face. This would all machine round and it would leave that bit left over, and we'd be finished with the chain ring here. First of all, for these plates, we have to drill holes, which is a preparation off that we don't really want to have to do. Secondly, these 5 holes here all have to be mounted to the jig using bolts. That takes time. We have to do that for the first op and the second op. They have to be done up and undone. It almost takes as long to load this machine as it does to actually machine the parts. So we are going to be changing manufacturing method shortly to a method somewhat similar to how we machine these. We are going to have a special jig made that clamps on the side like that, and we will be able to machine both sides at the exact same time, and the outside material will then snap off. This will also be loaded by a robot, which means we can run 24 hours, 7 days a week, and help us be more competitive.